my name is Waree and I'm here to present my final project on ingesting baseball statistics via Kinesis data stream for ingest transform load streaming pipeline. In this video, we are going over what is Kinesis data stream, why do we use Kinesis data stream, and my project's goal. AWS Kinesis data streams provide the service to collect and process large streams of data records in real time. In Kinesis data stream, the producer are the source where the data is produced. The data is continuously pushed from producer into Kinesis data stream, where the data is distributed across shards based on a partition key. Shards is a unit of capacity in stream, and each shard can ingest up to 1 megabyte of data per second. Producer specified the partition key. When the data is ingested into stream, it becomes records that consist of data block and actual data, partition key, and sequence number and ID to track down data. Records are stored in shards for 24 hours to 7 days. The stream is replicated across AWS availability zones, making it durable and fault-tolerant. Consumer reads records from shards and apply transformation and analytics. The consumer can use any custom applications such as Amazon EC2, AWS Lambda, or Kinesis Data Analytics and Firehose, or use AWS service to store data permanently such as Amazon DynamoDB, Redshift, or S3. Why do we use Kinesis data stream? This is because we're able to scale according to the size of data, handle billions of events, able for terabytes of data per day. It is also cloud native, highly available, fault tolerant, low latency for many concurrent consumers, able to receive data from many producers, and it is serverless streaming data service. The goal of my project is to take baseball game statistic of 3 LA Dodgers, Shohei Ohtani, Freddie Freeman, and Mookie Betts in duration of 3 months from March until May of 2024 and store it in a CSV file. This CSV file will be stored in a S3 bucket. Then we will use the Lambda function to simulate the streaming process from records in CSV to be ingested by Amazon Kinesis. The statistic will be partitioned by player's name. Then, streaming data will be transformed in AWS Glue by using ETL jobs and crawler to load transform data into data warehouse AWS Redshift. In Redshift, we will query and visualize the statistic of players to see who's the best batter so far in the season up until May. Now let's jump into the demo. So first thing first, we want to create IAM role or identity and access management role that we are going to be used with the whole process of building this pipeline. So I've created a role called data engineer where I have attached permission to all of the service that we potentially need to use, including Amazon Redshift full access, Amazon S3 full access, S3 object Lambda execution role, Glue console full access, Lambda full access, Lambda Kinesis execution role. Another thing to keep in mind is fixing trust relationship JSON document. If you do not put in the trust relationship for the services, then you won't able to attach the role to the Amazon services. So in here, I said for services, I want to include Kinesis, Lambda, Redshift, and Glue. So in S3 buckets, I've made 2 new buckets. One of them is called Baseball Statistic Dodger, and another one is Clean Baseball Statistic. So Baseball Statistic Dodger is going to be S3 bucket where Lambda will pull CSV file from to simulate streaming, and Clean Baseball Statistic bucket will be after we transform data by glue, we're going to put it in this bucket. So in Baseball Statistic Dodgers bucket, we want to set it up in a way that it will notify Lambda every time we put in new objects. So then Lambda function knows when to start streaming a data. We want to go to properties and we want to go to event notification. I name it new records. Event type, I put it as put. Destination type, I said Lambda function. And another one, I name it clean baseball statistic, which you can set all these settings as default. For the data of this demo, you can go to my GitHub Waree Protprommart and into my project LA Dodgers Cloud ETL, where you can find 2 CSV files in there. There are baseball player lambda tests, which consists of 3 records. I use it to test with lambda function, simulating streaming to the kinesis. And another one is baseball players March to May CSV file, which is a all records of LA Dodgers batter statistic from March till May in 2024. So here in Lambda function, I've made a function called stream baseball to kinesis, where S3 bucket is a trigger. And in a code, I wrote that every time S3 bucket notifies that there are new objects uploaded to the bucket, for it to get bucket name and get object key, then we download the file from S3 and read that CSV file. For each row in the file, I've set up for the code to skip the row that is not that is empty, and to record those rows that are not empty to be in JSON, and to be partitioned by player's name, and finally sent to Kinesis, the stream name Kinesis of baseball stream, sent the streaming data over and partitioned by player's name. After this process is done, it's going to print streaming to Kinesis completed in CloudWatch. If not, it is going to tell me what is the problem and print streaming to Kinesis field. So here in Amazon Kinesis and in data stream, I've set up baseball dash stream for Kinesis data stream. And most of the settings are default, in which data retention period is 1 day, where the records will only be kept in baseball stream, Kinesis data stream, only for 1 day. And in monitoring, you can see the sum of get records, iterator age, latency, and other statistics. Okay, so now we're going to upload a March to May statistics CSV file into Baseball Statistic Dodger bucket. Pull up. Okay, and we click upload. So now we're going to come over to CloudWatch for AWS Lambda, the AWS Lambda function, to see if the streaming is successful. Okay, so we have the log of today. So we would click on it. Okay, so we can see in JSON format for each row in the records. So we see Shohei Ohtani, Mookie Betts, and Freddie Freeman. So this means the records are sent successfully. Then we want to go to Kinesis to check if there's any new data coming in. So we can see that there are data coming in right here, incoming data sum and incoming data limits. In ETL job, I've made visual ETL called test run, where I am importing Amazon Kinesis into the ETL, and I choose Amazon Kinesis source as stream detail. The location of data stream is located in my account. I put in my region, the stream name, data format JSON, and I choose a starting position to be earliest. You can also choose the latest for continuous stream. And window size, I set it at 100. And we can see the data preview over here of what we have so far. Okay. Then we want to drop null fields in the data. And we want to drop anything that is empty string, null string, and -1 integer. We can also see data preview here too as well. We also drop duplicate too, in a way that we want to match entire row. Use all fields to compare between rows and only remove rows that match on all of them. Okay. And then we want to change the schema by where we are going to change from team to date. And we want to drop statistic including at bats, run, hit, total base, 2B, 3B, and we want to keep home run and bats in, but we want to change to integer for both. And then we want to drop base on balls, intentional walk, strikeout, stolen base, caught stealing. We want to also keep average and on base percentage. And we want to set it to double for both of them. And we want to drop other stuff. And lastly, we put the clean transform data into the S3 bucket called clean baseball statistic that we have set up earlier. And we said do not update the data catalog and uncheck the check data quality. Okay. So after that, we can save. And we can click on run. And we see the run details. and we could come back when it's done running. Hmm. Now that we have run the job for 19, almost 20 minutes, so we want to go into metrics and see if uh, most of the streaming job are being processed. We can see that um, all of the streaming data have been processed based on the graph of ETL data movement. We see a sharp slope here from large amount of data movement to low amount. And for ETL job running on streaming data, it would just keep running on continuously. And we have to manually stop it after we believe that most of data have been processed. So we're gonna go look into our clean baseball statistic bucket. So in here we can see that it made a folder to divide it by years, months, and dates. So there is a folder for just year of 2024. We will click in it and we click in month equals 12, day equals 11, hour equals 21. And here we can see that there are all the files that have been cleaned and transformed. So what we want to do is we want to uh, manually stop this streaming ETL process. Okay. Oh, so we click on the job, then we click stop job run. Okay. It says successfully stop jobs. Okay. And it is stopping. So I have set up a crawler called baseball crawler in order to read and scan the clean transform data and upload it into the database. And I have set the table of prefix that have been crawled as LA Dodger underscore stream underscore. And I also have set up a database called baseball stats. So in baseball stats database, this is a location where the clean transform data that have been through crawlers will land here. Okay, so now we're going to use baseball crawler to scan our clean transform data. So we click on crawler here, and we are seeing that it is running right now. Okay, so it is completed. Now we're going to go to database, and we're going to inspect. Okay. So we have player, date, opponent, home runs, run bats in, average, on base percentage. We also have in just year, month, day, and hour in addition, due to we want to know when is the streaming date. Okay. In order to use Amazon Redshift, you need both VPC and subnets in order to create Amazon data warehouse in Redshift. So for VPC, I created one called ITL 10.0-VPC. And for CIDR range, I set up as 10.0.0.0/24, which would give us 4098 IPs. I figured we didn't need to use a lot of IPs for the demo. So now we go to the subnets. So I create US West 1A and 1C private subnets. And for US 1A, the CIDR range is 10.0.0.0/25. And for US West 1C, it is 10.0.0.128/25. So each of the private subnet would have an equal amount of 128 IP addresses. I also set up a route table called private subnet route, where I do not open to the internet, and I routed for locals only 10.0.0.0/24, and also I have one routed to S3 bucket just in case. And next, let's go to Amazon Redshift. I have created Amazon Redshift with a namespace called Baseball Data Warehouse. The status is available right now, and the workgroup called Workgroup LA Dodgers. So let's click into Baseball Data Warehouse namespace. The namespace will host the database, which we have a database named dev in here. And if we go back to workgroup, so in here for workgroup, this is where we will host the server. And of course, for our Amazon Redshift, we have put it in VPC and have two subnets. Therefore, we have two availability zone for Amazon Redshift. So we could query and visualize data. And we would go to our workgroup LA Dodgers here. And we click on Query Data. Okay. So we want to click on Serverless Workgroup LA Dodgers. Okay, and then we want to click on External Database and AWS Data Catalog. And we go to Baseball Stats and we go to Table and LA Dodgers Stream Clean Baseball Statistics. Okay. And we can run this following query. Select all from AWS Data Catalog, Baseball Stats, LA Dodgers, Stream Clean Baseball Statistics. We want to click Run. So here we can see the queries coming up. Correct. Everything looks good. Okay. Okay, so next we want to be looking at especially two statistics for batter's position. That is an average of on-base percentage, which is on average, what is the percentage that the player hit the ball and make it safe to a base? And another statistic, which is total home runs they have made so far in this season. So those are going to be two statistics that will be best indicate how good of a batter they are in baseball game. So we want to query the following SQL query by select player, sum home run as total home runs, average on base percentage as average on base percentage from AWS Data Catalog, Baseball Stats, LA Dodgers Stream, Clean Baseball Statistics, and we want to group by players. Okay, we want to run that. Okay, so we see that Mookie Betts have made total 5 home runs so far in 3 months, and average on-base percentage is 0.65, which is the highest compared to Freddie Freeman, which is only 0.45, and Shohei Ohtani, which is 0.336. Freddie Freeman have made 2 total home runs so far, and Shohei have made the least total home runs so far at 0, 3 months in. So we can also visualize by making a chart. We click over here for chart. And for types, we can choose pie or bar graph, but I'm going to go with pie, and I'm going to use total home run as a value and players. Okay, so we can see here that Mookie Betts have made 70%, 71% of the home run, while Freddie Freeman constitute 28.6% in total of 3 of them. Okay, we can also look at it by bar chart for average on base percentage, such as Mookie Betts having 0.65% average on base percentage, which is the highest, and Shohei having the lowest. Thank you for watching my presentation.